1999 AMC8 problem 1. So we have this statement here, 6 question mark 3 plus 4, etc. And we have this statement here, and we want to make the statement true. So to make the statement true, the question mark between the 6 and the 3, so this question mark symbol right here, should be replaced by which of the following? So should it be replaced by division, multiplication, addition, or subtraction? Alright, let's write down the statement once again. Plus 4 minus 2 minus 1 equals 5. Now, what we could do is we could guess and check, right? We could plug in each of these mathematical operations into the question mark to see whether the statement is true. But that would be costly, right? Because that would take too much time. In this AMC8, you only have 40 minutes to do these questions. So a better way is to manipulate this expression so the only complicated part of this expression, the 6 question mark 3, is by itself. So everything else, it's quite easy to manipulate. So we have the 6 question mark 3. We don't know what that is. Let's keep it together. So plus 4 and 2 minus 1, that's just 1. So minus 1. So that's just plus 3 equals 5. So the 6 question mark 3, that's just equal to 5 minus 3, that's 2. Now it's relatively easy to see which symbol we should plug in. Clearly it should be division, right? Because 6 divided by 3 is 2. So the answer is going to be A, division. Problem 2. What is the degree measure of the smaller angle formed by the hands of a clock at 10 o'clock? So let's draw in the hands of the clock here. And so that's how it will look at 10 o'clock. And essentially we're going to be trying to calculate this angle right here. Alright, so we can see that this point, this is the center of the circle. So we're trying to calculate this sector angle right here. And that should remind you a lot of, so in order to do that, we need to find this part, this angle of this arc, right? Because if you remember, if you have an ascribed angle, and you know the length of this arc, let's call it angle of this arc, let's call it x. Then you know the sector angle, it's also x, right? So let's try to find the length of the angle of this sector or of this arc. Well, this arc, clearly it contains 2 of these equal arcs from 10 to 11 and from 11 to 12. Now we know the whole circle is 360 degrees, right? So that means each of these arcs, since there's 12 of them, right, because we have a clock. So if the whole thing is 360 and we have 12 arcs, then if we divide 360 divided by 12, that's going to give us 30. That means each of these arcs here, each of these is going to be 30. So since our angle that we want to find, it corresponds with this arc contains 2 of these small arcs. Each of them is 30, right, because we just calculated that. So this angle is going to be 30 plus 30, which is 60. That is going to be answer choice C. Problem 3. Which triplet of numbers has a sum not equal to 1? Alright, this is just quick addition, right? So let's look at A. So half plus 1 over a third. So half plus 1 over a third, that's going to be equal to, if we can quickly see, that's going to be a denominator of 6. And we have to multiply top and bottom by 3 in the first expression, top and bottom by 2 in the second expression. So that's 3 plus 2, which is 5. So 5 over 6, you still remember the 1 over 6. That's equal to 6 over 6, that's 1. So A is out. Because we want a sum not 1. So let's look at B. That's 2 plus negative 2 plus 1. The 2 and the negative 2 cancel out, that's 1. B is also out. Let's try C. 0.1 plus 0.3 plus 0.6. Let's ignore the decimal for now. So that's going to be 1 plus 3 plus 6. That's going to be 10. But adding the decimal, that's also going to be 0.10. Which is also, it's also going to be 1. Alright, so C is also out. Let's look at D. So D, we can add the first 2, because these are the positive. Let's try to add the positives together. Then think about the negative later. So 1.1 plus 1, that's 2.1. Minus 2.1, that's 0. That's not 1. So that means the answer choice is going to be D. Again, so obviously we could try answer choice C, but there's no point. Once we found our answer, let's move on. Problem 4. The diagram shows the miles traveled by bikers Alberto and Bjorn. After 4 hours, how many more miles has Alberto biked than Bjorn? Alright, so let's look at this graph here. Along the x-axis, we have the hours since they started traveling, and the amount of miles they have traveled at that hour. So we want to know after 4 hours how many more miles has Alberto biked than the other guy. Let's look at the 4-hour mark. 1, 2, 3, 4. So at the 4-hour mark, we can see Bjorn, he has traveled 45 miles. That's the B guy. At 4 hours, Alberto has traveled 60 miles. So that's Alberto. How many more miles has Alberto traveled than Bjorn? That's just 60 minus 45. That's 15. And that is going to be answer choice A. Problem 5. A rectangular garden, 50 feet long and 10 feet wide, is enclosed by a fence. To make the garden larger while using the same fence, its shape is changed to a square. How many square feet does this enlarge the garden? Alright, let's just draw a quick little diagram here. So we're going to have our rectangle, and we're going to change it into a square. So the rectangle, we know it's 50 by 10. Now to make the garden larger, we want to use the same fence. So we can see the fence, that's clearly the perimeter of the rectangle. Same thing with the square garden. The perimeter, or the fence, is going to be, right, it's going to be the perimeter. So since the fence is the same, that means the perimeter of the rectangle and the square stays the same. So let's find the perimeter of the rectangle. So that's going to be 50 plus 10, that's 60, plus 50, 110, plus 10, that's 120. So the perimeter for both the rectangle and for the square is 120. Now since a square, all 4 sides are equal, so that means one side, that's 120, divided by 4, which is 30. So each side of the square is 30. Now we can calculate the areas of each. So the area of the rectangular garden, that's length times width. 50 times 10, that's 500. The area of the square, 30 times 30, that's 900. So how much larger is the rectangle? That's 900. The area of the square minus the area of the rectangle, that is 400. So the garden has been enlarged by 400 square feet, or D. Problem 6. Bo, Ko, Flo, Joe, and Mo have different amounts of money. Now neither Joe nor Bo has as much money as Flo. Now both Bo and Ko have more than Mo. Joe has more than Mo, but less than Bo, who has the least amount of money. Alright, so in this question, let's just kind of draw the ends here. And what I like to do, we're trying to arrange from least to greatest, because we want to arrange, we want to know the least amount of money. So let's call this side the least side and this side the most side. So we know that neither Joe nor Bo has as much money as Flo. So let's say Flo is right here. Then both Joe and Bo are on the least side, right? They're going to be to the left of Flo because they have less money. So we can say Joe and Bo are like somewhere on this side. We don't really know their order right now. Now we know both Bo and Ko are also, by the way, these letters, they stand for the beginning of each name. For example, Bo, that would be B. Ko, that would be C. Hopefully you saw that, but that's just what I just have to explain that in case you didn't see it. So both Bo and Ko have more than Mo. So Bo and Ko has more than Mo. So let's see. So let's say we know Mo, he's really at the bottom here. He's even below Bo. And he's also below Ko. So we know he's below Ko. So Ko's also to the right of Mo. So these three guys, we're not too sure about their order right now. Now Joe has more than Mo. Alright, so Joe is to the right of Mo. Okay, that's good. But less than Bo. So Joe has less than Bo. Alright, that's also good. So now who has the least amount of money? That's clearly Mo. He's right at the bottom. So the answer is going to be E. And that's how I would think about this during a test. Is you could just draw these letters, and if you come to information that you haven't used, you add that in, and you just start rearranging the letters, and you could just look at the least here, which is clearly M, which is Mo. Problem 7. The third exit on a highway is located at milepost 40, and a 10th exit is at milepost 60. Now, there is a service center on a highway located 3/4 of the way from the third exit to the 10th exit. So, at what milepost would you expect to find this service center? All right, so let's call this the beginning of the highway, or 0. We know the third exit is located at milepost 40. So this is 40 miles along. We get our third exit. So this is the third exit. And obviously we want to draw a clear diagram to see what's going on here. And at the 10th exit, it's at milepost 160. So this is going to be 160. This is the 10th exit. Now we know there's a service center located 3/4 of the way from the third exit to the 10th exit. So we know that the 3/4 of the way, that's around right here. So we know that the exit is somewhere right here. I mean the service center, sorry. So we know that the service center, that's 3/4, or this part, let me highlight that, this part is 3/4 of the whole thing, right? Because we're 3/4 of the way from the third exit to the 10th exit. So let's calculate the highlighted region, the length. So we know that since this is 40 and this is 160, then this region right here, that's just 160 minus 40, right? That's going to be 120. So we know that this length right here is 120, right? Now we know that this highlighted region is 3/4 of this whole region, right? Because that's what they said. The service center is 3/4 of the way from the third exit to the 10th. So since this whole distance is 120, then 3/4 of the way, that's just 120 times 3/4. That's equal to 120 divided by 4, it's 30. 30 times 3 is 90. So the highlighted region is 90. Now we have all the information we need to find the length. So we want to find at what milepost would you expect to find this service center? Well, we would just want to find the distance from the origin to this service center. So we know the highlighted region is 90. This region is 40, right? Because the third exit is at 40 miles. So to 40, so to find this whole length, that's just 40 plus 90 to get to the service region. So that's at the 130 milepost. So that's going to be answer choice E. Then drawing a number line helped us visualize this question. Problem 8. 6 squares are colored front and back. So R equals red, B equals blue, O equals orange. So all these colors, right? You're going to color each of these, and they're hinged together like this, and they're going to fold them to form a cube. Now the face opposite the white face is what? Okay, now this question, it's going to be a little bit challenging. So what I like to do for these folding up a cube questions is to choose a face, preferably a face that's connected to a lot of the other faces, and think of that as the bottom face. So if you have like a box, for example, let's say you have a box, and we're gonna think of this Y as the bottom face, as this face, as the bottom face. So in this case, since Y, well, let me draw a bigger diagram so we can see what's going on here. Let me draw a larger cube so we can see what's going to happen once we fold it up. So this is going to be our cube. Let's draw that in. So the Y face, that's going to be the bottom face, right? That's going to be the bottom. Now, clearly this W, we're going to have to fold it up, right? It's going to have to fold up, right? So like the W, since it's connected to the bottom, we know the bottom is Y. So the W, it flips up. So the W, it's going to be right beside the Y. So it's going to be this face right here. Okay. Next, we have our O. This O, it's also connected to Y in a very similar way. It's just to the right of it. So it's going to flip up to the right of it. So the O is going to be on this right face. All right. Now let's do the same thing with the G. So the G, it's to the left of the Y. So it's going to flip up to the left. So G is going to be on this face right here. So now we have our main faces that are surrounding the Y. Now is the hard part where we come to R and B. Now let's see. So the B, look what happens to the B. We're going to fold up the G this way, right? The G folds up to the left of the Y, so it's going to be standing up like this, right? Now the B, it's directly connected to the G. So the B is directly connected to the G. So the B, as you can see, if you flip this guy up, the B also has to come up to be right here, right? Because the G, he folds up, and the B comes along with it to form the rest of our cube. So the R is going to flip up because the B. So what's going to happen is the B, it's going to flip around, so it's going to be at the back face here. That's going to be the B, and the R, since it's connected to the B, so the R is going to flip, also come along with the B, and it's going to rest on the top face R. Now this question, so now what's the face opposite the white face? Well, the white face is on this side, so opposite that's going to be the blue face, or the B, or answer choice A. So this question, I encourage you. These questions, folding up cubes, it's actually really important. Because once you visualize these questions, you'll always be able to do them no matter what. Because so what I recommend is at home, you cut out this configuration and just start folding and see exactly what I mean here. Because it's kind of hard to explain the folding process on camera, right? On video. So you should try that at home. Problem 9. 3 flower beds overlap as shown. Bed A has 500 plants, bed B has 450 plants, and bed C has 350 plants. Now beds A and B share 50 plants, beds A and C share 100 plants. The total number of plants is, in this question, it should remind you of a Venn diagram, but it's just a more confusing Venn diagram, right? A different variation. So we know bed A, the whole bed A, is going to be 500, right? Bed B has 450, and bed C has 350. Now, beds A and B share 50 plants. So we know the share region, or this overlap region, that's going to be 50. So in these Venn diagram questions, what you always should do is first look at the overlaps. And then from there, you can move on out. So beds A and B share 50, so we know that this overlapping region is 50. Beds A and C share 100, so we know the overlapping region for A and C, that's 100. Now, let's calculate the rest. So looking at bed B first, well, what is the rest of this region here? Well, the rest of this region, well, since the whole region is 450, and already 50 of the plants, there are in this overlap. So how many are in the rest? That's just 450 minus 50, that's just 400. So in the rest of this region is 400 plants. Let's do the same thing with C. Since the whole bed is 350 plants, and it shares 100 right here, then there's going to be 350 minus the 100 as well. So that's going to be 250. So just in plant C alone, that it doesn't share with anybody else, that's 250 plants. Finally, we have A, the rest of this region, that it doesn't share with anybody. So we have the whole thing, that's 500. And we have to subtract away these two regions, right? Because we are not going to include them in the rest of this region. So that's 500 minus the 100 minus the 50. That is 350. So in the rest of this region, that's 350. So now we can add up all three of these individual little regions to get the total number of plants, right? So that's going to be 250 plus 100. 250 plus 100 plus the 350 plus the 50 plus 400. Let's add it up. 250 plus the 50, that's just 300. 300 plus 100, that's 400. So that's 400. 400 plus 400, that's 800. 800, and we still have the 350, so 800 plus 350, that's 1,150. That's answer choice C. That's going to be an answer. Problem 10. A complete cycle of a traffic light takes 60 seconds. Now, during each cycle, the light is green for 25 seconds, yellow for 5 seconds, and red for 30 seconds. So at a randomly chosen time, what is the probability that the light will not be green? Okay, so first of all, we can see that, let's say we have our timeline again. Our timeline over a course of a whole day, how at each point what the traffic light would look. So let's see. Let's look at the first cycle here. So we can split it up into cycles, right? Because it's going to be cycle, cycle, cycle. So each of these is a cycle, right? And now what we can see clearly is each of these individual cycles, that's the most important because the cycles are repeated over and over again. So you don't have to consider all of the cycles, right? You just have to consider the probability in one cycle, and then it's going to apply to the rest. Because, again, we're looking at probability here. In probability, it doesn't matter as long as your cycles are repeated. And clearly they are. So let's just look at an individual cycle. So, because all of the cycles, like I said, are completely identical. Let's just look at one individual cycle. So we know that it's going to be 5 seconds is going to be green. 5 seconds is going to be yellow. And 30 seconds is going to be red. So at a randomly chosen time, we're just going to look at this one cycle. What is the probability the light will not be green? Well, that means it's either yellow or red, right? So so we want a total. So we have the total in the bottom. In the numerator, we want not green. So in this cycle, clearly there's a total of 60 seconds. In the numerator, we don't want the green, so we're going to add up the rest, which is 5 plus the 30, the yellow and the red. That's 35 over 60. We can reduce by canceling a factor of 5. That's 7, that's 12. So our answer is going to be 7 over 12. And since this applies for the one small cycle, this probability is for this one small cycle, it's also going to apply over a randomly chosen time, like across a whole day, right? Because each of these cycles, like I said, are completely identical, so you only have to look at one cycle.